All right, lesson 5. Now, concentration is the amount of solute dissolved in solution. For something to be dilute, there's little solute in solution, and concentrated mean there's lots of solute in solution. So now we're going to practice calculating percent by mass and percent by volume. So percent by mass is the mass of the part, or the solute, divided by the mass of the whole, which is your solvent, times 100%. Percent by volume is volume of the part divided by the volume of the whole times 100%. So, first example, what is the percent by mass of glucose if 2.8 grams of glucose is dissolved in 100 grams of water? Well, percent by mass is the mass of the part, which is our glucose, divided by the mass of the whole, which is 100 grams of solution, times 100, and we get 2.8% glucose. So now we'll do an example using percent by volume, and percent by volume is here. What is the percent by volume of alcohol if 40 milliliters of acetone is diluted with water to form a total volume of 300 milliliters? So percent by volume is the volume of the part, which is 40 milliliters of acetone, divided by the volume of the whole, which is 300 milliliters, times 100, and we get 13.3%. And this is of acetone. All right, so now we're going to do parts per million. Parts per million is used a lot in regards to water and like water we drink. So if you ever happen to see a water bill come in to your parents' home, and they will sometimes annually send a parts per million report, now you know how they actually get the numbers. So a sample of water is found to contain 0.01 grams of lead in 15 grams of solution. What's the concentration in parts per million? Well, parts per million is the mass of the solute divided by the mass of solution times 1 million. That's where the 1 million comes in. So I have 0.010 grams of lead, and I have 15 grams of solution. Multiply that by 1 million, and we get 670 parts per million. Parts per million of what? That is of lead. Now on the next page, we're going to deal with molarity. Molarity is the moles of solute divided by the liters of solution. So for example, a solution has a volume of 2.5 liters and contains 0.7 moles of sodium chloride. What is the molarity? Well, molarity is the moles of solute divided by the liters of solution, and we get the answer of 0.828 molarity, and that's the molarity of sodium chloride. So when you see all the brown bottles we use in class, now you can see where the molarity actually comes from. So determine the molarity of 3 moles of sucrose that are dissolved to make 2 liters of solution. So we start with 3 moles of sucrose, and we will divide that by 2 liters, and we get an answer of 3 divided by 2 is 1.5 molar solution of sucrose. All right, next one. Determine the molarity of 2 moles of sodium chloride dissolved in 8.2 liters of solution. So we take 2 moles divided by 8.2 liters, and 2 divided by 8.2, we get 0.24 molar solution of sodium chloride. All right, one more practice and then you're going to be on your own. All right, so determine the number of moles of salt dissolved in 500 milliliters of a 0.5 molar solution. Now this one we have to actually find the number of moles. So now my equation is 0.5 molar solution equals X divided by 500 milliliters. So to solve for X, we multiply 0.500, because remember it's in liters, so 0.5 liters times 0.5 molar. So 0.5 times 0.5, I get an answer of 0.2